Welcome back friends, this is Fraser from Art Studio.
Do you want to create something like this in Maya where you learn how to tear a cloth and simulate it naturally? Then let's get started. Let's first create the basic setup. So we take a polyplane, we'll add subdivisions to it. Try to add at least 50 subdivisions in both the axes so that you get enough density for smooth deformations. Let's name this as cloth mesh. Next, we'll be creating the poles just to show the support at the four corners. So we'll take a cylinder for that, polyprimitive cylinder, and we will size and scale it a bit. So we'll use snap to vertex and snap it along the vertex. Then we'll mirror it along the x-axis and z-axis. Once that's done, our poles are ready for support structure. That's just for visualization purpose. Name it as pole mesh. Next, let's create the ball which is going to fall on the cloth, creating the tear for the primitive sphere. I already have all my tools and main assets on the shelf. So I'll delete the history and freeze transformation of each of this and name this as the ball collider mesh. So our basic setup is ready very quickly. Now let's start working on the main part. So this cloth mesh fabric is going to be a nCloth. So for that, you need to go to the FX menu. So come down to the menu shells over here. And by default, if you are into some other shelf, then scroll down to the FX. And as soon as you get into FX, the menu options changes. You have the nCloth option over there and scroll down to nCloth. As soon as you do this and you play animation, you'll see it falling down under gravity. Let's first add a few more frames. We'll keep it to 120 frames and we see that it's going down under gravity. So it has to be restrained or constrained along certain points where it can be held and the deformation will take naturally according to the physics. Okay, so for that we will be selecting the corner vertices, okay, from the top view, turning on the wireframe mode. I'll be selecting a couple of vertex with smooth selection, as you can see over here, along the corners. For all the four corners. So once that's selected, we'll go to the end constraint menu. And under the end constraint menu, if we just scroll down, we'll select the transform constraint. So now, as you can see, these four corner vertices we have selected have become constrained. Once that's done, as you can see, we have these constraints over there, point, and also the locator created for the cloth. If I play the simulation, if I play the animation, you can see how it's very naturally deforming under gravity as the central part goes down, and these four corners are held by the constraints we have just applied. Next up, let's go and create the tearable portion. So the portion of the mesh of this cloth in the center, which is going to be torn out by the collision of the cloth of the ball. For that, we need to select the portion. For that, we'll be going to vertex mode and take the paintbrush, a paint selection mode, and then we will use the soft selection and just paint this area about a centrally located circular area, since it's a circular ball. If you want, you can keep a random kind of shape also for this. And once that's selected, we'll now be going to end constraint, under end constraint tearable surface. So we'll change this to tearable surface. Okay. So once that's done, this portion has become tearable. It can be torn out once the animation runs along with the collision, right? Now let's animate this ball. So the ball is at a certain height. Let us key this portion on the first frame before it falls down. And let's go to the 20th frame and then move it down on the grid. So this will be a basic animation. We won't do any kind of a bounce or any kind of physics on this. We'll just move it across the plane to get the main thing we are looking for, that is the tearing the cloth. So once these two keyframes are set, once that's done, select the ball and create the ball as a passive collider. So under the options, you'll find of nCloth, you'll find passive collider option. So turn the ball into a passive collider. So that way, when it collides with the cloth, it is going to create the tear. Now, for the visualization purpose of the tone particles, I'll just create a simple plane so that we can see where the planes are going. As you can see, these planes after tearing out, the mesh is all going here and there, even going down into infinity kind of zone. Okay, continues animating as long as the frame is there. Let's apply a few colors so that we can visualize it better. So I'll apply different materials to the ground plane and to the trampoline. So now we can visualize once the animation is played.
If I turn the wireframe on, you can just see it. It is going to just keep falling down to infinity, so to speak, going into some kind of void, it seems. So to avoid this, go to the attribute editor. Just select the Nucleus node, Nucleus 1 node, either from the attribute editor or from the outliner is easier. And then you see one option, which is the use plane option, right? So if you click on that, so using the grid, not just this mesh is created just to make the visualization more clear. So the grid basically will act as the plane, okay? And once we play the animation, you'll see what's going to happen once it's torn. So as you can see, once it's torn now, it's not going and falling under gravity into infinity. In fact, it's sliding over the surface of the grid. And since I've created a plane on the grid itself, so we can visualize it clearly, gliding over the surface, right? So that is one tip for you. Okay. So now currently, as you can see, with what we have over here, the particles are sliding off, right? So if we increase this friction, let's try 0.5 and let's run this once more. So it's not going to slide off like that. It's going to remain closer to the impact area. Okay. We can increase it even further. Let's make it 1 and see. Okay. So this looks more natural. Okay. So with the nCloth node selected and the attribute editor Nucleus 1, you can go to the Nucleus 1 from here. Okay. It's the same node and you can increase the plane friction. So if you increase the plane friction, basically these particles or the tone pieces will not slide off. Okay. Like how it was sliding off earlier. You might have a few pieces going a little further, but it looks more natural based on the impact and the material. Okay. So this is one tip which you should follow and make this change. There are other things like plane bounce and all. If you want the pieces to bounce off the floor, that depends on what kind of fabric you have and what kind of plane you have. In this case, we don't want it to bounce, so we can leave it like this. So you can play with these values.
So there's one more thing I'd like to discuss with you regarding the properties of this cloth or the fabric, um, based on which it stretches or remains rigid. So let's see. So basically, if you select the dynamic constraint 1 from the outliner, or you can go to the attribute editor and select the dynamic constraint shape 1 node. Okay. So if you select this node, and let's first play once more and see what's going on over here. So this is how it behaves currently under gravity and under the effect of the interaction with the ball as it tears. Okay. And how elasticity plays its role in its bounce and stretchiness. So if you come over here to the attribute editor under the dynamic constraint shape 1. Okay. So basically the shape 1 node, if I just stop it for now playing, the shape 1 node is controlling the cloth. Okay. But not the entire cloth. just the portion which has been attached to these poles, constrained to these poles, and leaving out the portion which is tearable basically. And if I just highlight this, so this is the locator created, which is controlling that. And if I select dynamic constraint 2, this is basically controlling the tearable portion. Okay, the portion which had been made tearable, not as in terrible portion. So which will tear from here. So that is controlled by dynamic constraint 2 shape node. Okay, and then my constraint one shape node is controlling rest of the fabric, okay, which is being held by these constraint points along the pole over here. I mean, not the pole, the mesh itself. The pole is just for kind of giving an illusion to just for the visualization purpose. So anyways, so dynamic constraint one is controlling the rest of the cloth which is not being torn. Okay, so if you go to the attribute editor, once you selected the dynamic constraint one node or the dynamic constraint shape one node as in the attribute item. And if you just scroll down a bit, you can see the glue strength over here, okay, under connection density range. So you have the strength and then you have the glue strength. Okay, so the glue strength, as you can understand from the word, the gluiness or the strength holding it together, the form or the elasticity or the rigidity of the cloth, so to speak. So now currently it's 1, okay, for the rest of the cloth, which is not going to tear apparently due to its glue strength. Now, if I just go back to the first frame and try to change the glue strength. So currently you can see the glue strength scale is not highlighted and not selectable. Okay, since the value of your glue strength is 1. Okay, so as soon as we change this value, let's say to 0.5, the glue strength to 0.5, this glue strength scale value becomes selectable or editable now, right? So it is by default zero point 0.5. So let's make it little less and let's say go with zero point 0.1 and see what happens. So as we see, without the interaction of the ball, when we reduce the glue scale to zero point 0.1, the entire cloth falls down under gravity. And if I just run the simulation, it will very naturally, like a rubber sheet kind of a thin sheet, folds and unfolds with the motion and the stickiness it has, right? So that's what is happening with the glue strength scale now. So if I just get back the glue strength as zero point 0.5 and reduce the the scale as zero point 0.5 and the glue strength to 0.4. So you can see how it crumbles down, okay, and it falls before interaction. So it's not holded by those constraints anymore, but it gives a nice form of a kind of a cloth which has been just kept like that in a very messy way. You can use this nCloth option and just get that. So you don't have to do any sculpting. Just use a simulation and then ready to go. Fine. So there it is. So if you want something stretching like this, let's say 1, and let's see what happens. So now under gravity, you can see that portion is going to help the cloth to get pulled down by the force of the ball. So let's deselect this and let's hide this constraint for now. So we get a better visualization of what's happening. So that's there. And when the ball comes in, it pulls in and the force of the ball pulls the entire thing down. So this is a very important tip or an interesting thing which you can use. Simply use the dynamic constraint 2 over here, okay, and increase the glue strength to 1, as simple as that, okay. If you want to refine a little further and make it more realistic, then you can try with this value, which is creating a tear as well as it pushes down. So simply the dynamic constraint 1 uh, glue strength is 0.3 and glue scale strength scale is 1. Okay, you can take a snapshot of this value. And for dynamic constraint 2, basically this glue strength I have kept it as zero point 0.5 and the glue strength scale as zero point 0.5. If I make this 1, okay, and then play it, then what is going to happen is it's going to pull it, but it's not going to tear it. So if you want something like this, then this value point of 1 will do. Want it to tear a little bit, want the cloth to tear a little bit, then you can reduce the glue strength so it doesn't hold it so firmly, that tearable portion, and so it tears. You can decrease this a little further to increase the amount of tear if you want. So let's make it 3.3. Let's see. So as the ball comes, it tears and then it falls off. Okay, so it tears, and on impact, then it snaps from outside, and the force holding it, the constant, is not enough, and it tears off, and just not just tears off, but it slides off over the ball, and so naturally you can see all the effects taking place, all the physics taking place, the torn pieces flying away, and you can also see the cloth simulation on the gravity, the cloth simulation interacting with the ball on tearing, and also as it uh, snaps out of the constraint held points over the ball. So I feel this sums up the entire tutorial, covering all the aspects and the nodes. And so you can play with this to create all these different kind of variations as per your requirement for the scene. And so you can apply it in different kind of situations, scenarios, and physics. So thanks for watching. If you like the video and you've seen the entire video till the end, don't forget to give a thumbs up. Feel free to comment, and if you have any queries, you can let me know. And friends, if you haven't subscribed to my channel yet, please do hit the subscribe button. I hope this tutorial helps you, and subscription will help me as well. So let's grow the community as greater and faster as possible. And see you in the next video. Till then, goodbye, take care, stay safe, and love you all.